All right, dude, we are live. What's up, guys? This is Dem Keys, and give me a second because despite me starting up my VTuber application before the stream, it suddenly stopped. It stopped picking up the mic signal, so I just need to open it up again, and then we can continue. Okay, check, check, testing, testing. Okay, now we are good. Let's place. Um, yeah, I think that's good. Let me just see how that looks. That looks great. Okay. And let's also make sure the browser is being captured and we are good now. Okay. All right. What's up, guys? This is Dem Keys, and today we are. Sorry, I blanked out. Today we are gonna be continuing learning about Git, remotes, branches, and there was one more thing. Bare repos. Yeah, we're going to continue learning about that. So yesterday, I don't remember if it was on stream or off stream because I did continue having a couple of different conversations with Gemini regarding different scenarios using Git. I can read out a couple of them. Hold on. Just give me a second here. I also need to open up those conversations, so let me just load them up. Okay, there was one conversation. I can't remember which one I had started up on stream, but off stream, I kind of branched out into a couple of other conversations as well. I just need to reload those conversations. So one of them was me trying to understand. Oh, okay. So couple of things, right? One, I wanted to learn about bare repos and understand the concept of bare repos, how they work, how they are meant to be used, and stuff like that. I have very basic understanding of bare repos, and that's just to say that it contains um, the Git repo itself. It doesn't contain a working tree. You can't really make commits to the repo, um, but that repo does contain the all the commits and branches, and all the repo related stuff is stored in that repo. The only thing you don't have is a working tree, so you can't make commits to it. What you can do though is push branches to it and pull branches from it. So you can push. Actually, you can actually push commits as well. I mean, when you push the branches, you are pushing the commits that were on that branch. So it's the same thing, and it's a similar thing with pulling as well. So you can't make commits to it directly, but you can use it as more or less a central repository where you can push changes and you can also pull changes from there. Pulling is fetching and merging, and pushing, I should actually look into what what operations are involved in pushing, because as far as I know, with fetching, you fetch all of the information about the or all of the latest data from the remote repo. This includes all the branches and therefore also all the commits, new commits, the latest commits, stuff that you don't have. It's going to pull all of that. I believe it also pulls tags. I have to look into what other information it's pulling, but fetching pulls all of that information. Then you do a merge. Merging is when you merge a branch from the remote repo into one of the branches in your local repo. Now, when you fetch and this is just me like reiterating what we learned yesterday, what we explored yesterday. When you run a fetch operation, Git creates something called remote tracking branches, and these are basically the branches of the remote repo being stored locally. So all the changes that have taken place, all the changes that have happened, all the new commits and stuff that have happened, all of that information is going to be stored. However, it doesn't get merged directly into your active working branches and stuff. It gets stored into something called a remote tracking branch. For each branch, there's going to be a separate remote tracking branch. Okay, great. Once you have this information, you can then decide which of these branches you want to merge into your local branch. So you would then be merging one of the remote tracking branches into one of your local branches. This is about all I know when it comes to bare repos and how you're supposed to be using bare repos, how bare repos work. But that's why I want to get a better understanding of it, because I feel like that understanding that I have is not it's not enough. The level of understanding that I have is not enough. Additionally, I was also looking into GitHub related stuff, more specifically, how I would set up the GitHub remote and how I would push commits to the remote repo and pull commits from the remote repo. I I will rarely be pulling commits from there. It's most likely going to be pushing most of the time, because I have one working copy there, and I'm the in like pretty much all of my projects, I'm the solo dev working on my projects. I don't have collaborators, so I don't have to pull changes. I don't have to fetch any information I before I push, or before I do my work. The central repos, the two central repos that each of my projects is going to have, they are solely for the sake of having central repos and solely for the sake of having backups. So my local central repo is going to be so I have a local backup, and my GitHub central repo for that same project, by the way, is going to be so that I have a cloud-based or GitHub-based backup. That greatly simplifies things for me. Actually, that greatly simplifies things for me. Not having collaborators, it'll make my workflow a lot easier in terms of, you know, pulling stuff and pushing stuff, more specifically pushing stuff. But yeah, I wanted to understand the workflow because I couldn't remember what the workflow was with GitHub. I did do it at one point in time. I did do it, but I haven't done it nearly enough, and I haven't kept up with the practice, so that's why I just forgot the workflow. But I remembered some bits of it. I remembered that I had to use GH, um, which is the GitHub CLI, or it's the GitHub command line. I can't remember which one it was, because I think they were two different tools. Whatever, GH. Actually, let me look that up. Wait. Oh, I could look it up here, right? I'm pretty sure I still have GH here. So, oh, it is GitHub CLI. So in GitHub CLI, there's a auth login subcommand. You can see here it says gh auth. So if I do this, hopefully it's gonna, yeah. So we have gh auth login. Um, you call this command, and then there's a certain workflow that's followed in order to get you logged in. You don't type in passwords anymore. You mainly use I forgot what they're called, personal access tokens, I think. Yeah, basically they'll give you a token that you would have to um, tell this GitHub CLI about. I don't remember if you have to manually enter it or if they have some sort of auth workflow set up where the moment you run a gh auth login, it's going to pop up GitHub in your browser and then ask you to, allow it or give it permission or whatever. I don't remember what the workflow was, but once you complete that workflow, it's going to store the access token um, locally in one of your files, and or it probably has like a secure way of storing that as well. And further from that point, anytime you want to push something to your GitHub account, you won't need to log in because you already have your information, your login credentials stored. So at that point, um, my workflow is going to become significantly simpler. I'm gonna have the central repo, which is local, so it's only gonna be using like the file-based protocol. Speaking of which, yesterday I had opened this thing up. Actually, I just remembered something that I forgot to check before starting the stream. So I'm just gonna check that. In the meantime, I'm just gonna make this thing vanish. Um, Give me a second, and we are good. Great, awesome, awesome. Okay. Should be back now. Yes, it's back. Okay. Yesterday I had opened up the page for the protocols. So there's four protocols being mentioned here, I believe. I don't remember. There are, oh yeah, it says Git can use four distinct protocols to transfer data: local, which is the file-based protocol; HTTP, SSH, and Git. Here we'll discuss what they are and what the basic circumstances you would want, and and in what basic circumstances you would want or not want to use them. So we're going to be reading this today as well to understand this. I also want to just clear up my confusion about SSH versus the Git protocol, because I don't remember too much about the Git side. Because you do have the SSH side where you enter like um, you enter the username. The typical way of logging into SSH is the account, um, the username of a account on that machine, followed by followed by some sort of address of that machine. So it could be an IP address. For example, if I need to SSH into the machine that I'm currently running this tmux session on, usually I would do SSH dem keys, that's the user account name, at 192.168.8.100. That is the IP address of the machine, uh, the machine that I'm trying to access on my local network. Okay, great. Now, if I have a tool that does things over SSH, like for example, the SCP tool, which can be used to transfer files over SSH, transfer files between machines over SSH. Um, I would do this basically dem keys at so and so address, and then I would put in a colon, and then I would give the file location. So let's say it's home, dem keys, scratch stuff, empty dir, and then let's say there's whatever file in there. So that's going to be our source. Then our destination would be wherever on the local machine I want to place the file. Just imagine that I'm running this command on a remote machine, and because right now I'm typing it out in the same machine where I'm, you know, the machine that I'm typing this out in is actually that machine. But yeah, this is how you would use this. Now you have the SSH. Let's call it the SSH tag. I guess I'm not sure what to call it, but if you want to address the file um, over SSH, and you want to give an address for a file that's meant to be accessed over SSH, you would do it like this: dem keys at 192.168.100, and then colon, right? Then you type out whatever your entire file path is on that machine. Git has a similar thing going on. Not Git. GitHub apparently has a similar thing going on when you're accessing stuff, pulling and pushing over SSH, because they allow you to do it over SSH. They also allow you to do it over HTTPS. I need to look into both of them and see which one I had used. I believe each time I do a Git clone, it is using HTTPS. Let me open up the tick git repo and try to clone from there. Now I'm gonna copy the strings that they give you, and I'm gonna paste them in here. So we go to code, and yeah, it's HTTPS. Oh, there's also a thing for GitHub CLI. So there's three different commands that they give you. I could just open the thing up here, but I'll type the thing, not type. I'll copy the thing and paste it. So I could put it in here rather than typing it out there. So this is the HTTPS method, and this is what I usually use for cloning. So I do git clone. Let me type that out as well. I do git clone so and so. Then the other method that they've given is for SSH. It mentions here you don't have any public SSH keys in your GitHub account. You can add a new public key. I don't have a public facing SSH stuff set up. I also, just in general, I don't have SSH keys set up. I never took the time to, set up that whole thing because I was perfectly fine with having to log in each time. It wasn't really much of a security concern for me because, well, I'm the only one, doing anything on this network. So it wasn't too much of an issue, but I'm going to type out what the SSH thing looks like. This is what the SSH address for tick git looks like. So you can see it says git at github.com. So that's our entire, I'm not sure what to call this, but let's call it like in the entire address. Then a colon followed by a way to access this directory on GitHub's server that's giving us access to this repo. The majority of the time, I've used the HTTPS method for cloning. I've rarely ever used the SSH method. That being said, I should look into whether I want to use the SSH method or the HTTPS method. Because if login is not an issue, then I don't see a problem with just using the HTTPS method. I don't know what the advantage or disadvantage would be of using the HTTPS method over the SSH method, specifically for uh, pulling from and pushing to GitHub. I could try asking Gemini. Actually, I do have a couple of these Gemini conversations open. I have some GitHub related pages open as well. Um, learn the GitHub flow and the key principles. Okay, that's fine. Open a pull request. Okay, all right. Merging branches. That's fine. Importing source code. Git remote add. Push. Okay, what's the remote that's been added? Push remote so and so. Rename. Okay. Pushing tags. Deleting. Remote add upstream their remote URL. Okay, from HTTPS so and so. Okay, you know what? Um, let me open up a conversation with Gemini and ask, hey, so I'm learning Git. I'm wondering if I spelled wondering wrong. wondering if I set up, sorry, zoned out. Okay, if I set up a central um, repo for my project on GitHub, um, but I had a local copy that is basically my working copy. When I add when I add the central repo as a remote in the working copy, should I be, by the way, there was one more. I did not, I don't know where the repo is. I think I closed it. There was one more, um, which was gh repo clone. It would look something like this: gh repo clone, and then this tick git dot git. I don't know if the dot git is necessary there. Hold on, let me look at the other. Yeah, probably not necessary here. So that's another way to clone the repo. The majority of the time, what I've used is just git clone. I rarely ever touch either of these. I'm probably not going to be touching the GitHub one, but I want to see I want to see in what situations I would be using the SSH one. Okay, back to the question I was asking. Hold on. Okay, yeah, should I be using the HTTPS or SSH URL provided on the repo's uh, GitHub page? In what situation would I be using each of them, and how am I meant to be using each of them? Um, I've often cloned repos off of GitHub, but the majority of the time I've just used the I've just used git clone and provided the HTTPS link of the GitHub repo. I just remembered that I forgot to open up my chat on my phone, so give me a second while I do that, and then we can continue. Let me also make sure that we are good on frames. Yes, we are good. Okay, that's odd. It's not showing on my in my Twitch app. Oh, there it is. Okay, I just had to re launch the application. Okay, cool. Okay, Gemini replied saying, it is completely normal to start out using HTTPS for everything. It is the default choice for GitHub Highlights. No, it is the default choice GitHub Highlights, and it requires zero setup to get started. But once you start pushing code back up to your own central repository, SSH usually becomes the better choice. Give me a second. Okay, the thing got stuck. Oh yeah, okay, it's stuck because of the amount of tabs I have opened. I noticed something with The with the updates that have happened to the web version of Gemini, I think it has started consuming more RAM, like per Gemini tab, I mean. Yep, that's the problem. That is the problem. So I just need to free up a couple of these things. Just give me a second here. Sorry, I'm just trying to fix the thing. In the meantime, while this is getting fixed, what was I talking about? So I was mentioning that I usually use HTTPS. Okay, finally the menu popped up. Let's unload the tab. Oh, great. It started loading up more tabs. Give me a second here. I'm just trying to free up some resources here. I might need to crash a tab. Okay, yeah. In the meantime, while that fixes itself, I can continue reading this, or I guess start reading this. Okay, Git can use so and so. Yeah, okay, we've read that. So the first protocol is the local protocol. The most basic is the local protocol, in which the remote repository is in another directory on the same host. It is often this is often used if everyone on your team has access to a shared file system such as an NFS mount, or in the less likely case that everyone logs into the same computer. The latter wouldn't be ideal because all your code repository instances would reside on the same computer, making a catastrophic loss much more likely. Okay. Um, if you have a shared mounted file system, then you can clone, push to, and pull from a local file-based repository. To clone a repository like this, or to add one as a remote to an existing project, use the path to the repository as the URL. For example, to clone a local repo, you can run something like this. So basically, it's just git clone and then the directory path. Additionally, they're saying you can also use the file, whatever this thing is called. You can also use that. Okay. Um, Git operates slightly differently if you explicitly specify file at the beginning of the URL. If you just specify the path, Git tries to use hard links or directly copy the files it needs. If you specify file, it fires up the process that is normally used to transfer data over the network, which is generally much less efficient. The main reason to specify the file prefix is if you want a clean copy of the repository with uh, extraneous references. Extraneous? How do you that? Oh, that sounds wrong. Nope, extraneous. We're sticking with extraneous. Um, ex is it extraneous? I extraneous. I don't know. I'm going to look up how you're supposed to say that word. But yeah, extraneous references Objects, extraneous references or objects left out. Okay, generally after an import from another VCS or something similar. We'll use the normal path here because doing so is almost always faster. To add a local Git repo to an existing Git project, you can use something, you can run something like so and so. Okay. Uh, then, then you can push to and pull from that remote via. This is something I need to explore further explore further through Gemini. Is the fact that okay, we have this bare repo, right? Once we add this bare repo as a remote in one of our other projects, we are just able to push stuff to it and pull stuff from it, which I find really interesting. Something that makes it even more interesting is a question that I had asked Gemini yesterday. I posed this scenario to Gemini that let's say I have two different projects, okay? And in each of those projects, I have, so let's say we have Proj O1 and Proj O2, and Proj O1 has a branch called Branch O1. Proj O2 has a branch called Branch O2, just for the sake of having two separate branch names. So we have Branch O1, which belongs to Proj O1, and Branch O2, which belongs to Proj O2. And let's say I've added our central repo as a remote in both of these projects' repos. And then I decide to push from both of these repos into the central repo. What exactly is going to happen? Like, how is that being treated exactly? Are they getting merged together? Are they joining in some way? Are they just gonna, is one just gonna be, declined, or what's gonna happen? According to Gemini, this is very much possible. However, it's not recommended unless you absolutely have a good reason for doing it and you know exactly what you're doing. Because um, what this leaves you with is one repo that has multiple roots, multiple root trees, and that may have its use cases, but generally it can become a little hard to manage. So unless you know what you're doing, and unless you have a very good reason for doing that, probably stick with having, multiple central repos because it keeps things simpler. I'd imagine it would also be combining all the Git objects together. So we'll have like two root commits. Each of those two root commits are then going to be they're going to have their own tree objects. They're going to have each of those trees is going to have its own um, blobs. Um, each of those trees is going to have its own blob objects and its own like subtree objects, and these are like they're connecting to each other, so it's not like they're getting like jumbled together, but they're being stored together, but they're connecting to their own previous roots. They're not mingling with each other. The only thing is they're being stored as one thing. I don't think they would be stored as two different object. We could try experimenting. It wouldn't be that hard for me to set up. It would just take, a little time to set the thing up, but I could easily set up something and like push main from one and push main from another. That would actually be another interesting thing to look into, is what if the branches are both the same name? So what's happening in that case? Are we renaming one of the branches? Is there some sort of merge conflict occurring? Is that where we're going to end up in a mess? That would be something interesting to test out. That being said, I'm not going to do that. I'm not planning on doing that. If I did do it, it would be by mistake, meaning I would then try to fix that mistake. Okay. Um, that being said, let's continue. So then you can push to and pull from that remote via your new remote name, local proj, as though you were doing so over the network. The pros of file-based repositories are that they're simple and they use existing file permissions and network access. if you already have a shared file system to which your whole team has access, setting up a repository is very easy. You stick the bare repository copy somewhere everyone has shared access to, and set the read/write permissions as you would for any other shared directory. We'll discuss how to export a bare repo copy for this purpose in getting Git on a server. We should read that as well. Is that part of this chapter? Git on the server. Oh, that's the next chapter. Okay. All right. Give me a second here. The browser. I had to crash the other browser so I could, well, reopen the thing. Um, okay, Git remote. Okay, we've got this, we've got this, we've got this. Okay, Git. Yeah, okay. Another thing, Gemini mentioned that apparently the workflow that I was trying to set up, where I have my local working copy, and there's also a local central repo, and then there's a remote or a cloud-based, so GitHub central repo as well. Apparently, this is called a triangular workflow. Let me, let me. I don't know if Gemini was just like making up that name or if it actually is called that, but this is what Gemini mentioned. It's called a triangular workflow. And this also seems to be a common thing where you will have your own local backup. Because that's the whole idea. Like, I want to have I want to be hosting the thing myself, but I also want to have it up on GitHub. Just, at least for the repos that are not meant to be private projects, I want to have them up on GitHub. Though, that being said, GitHub does allow private repos as well. GitHub does allow private repos, so I can decide if I want it to be a private or a public repo. And the way to access it would still be the same if I'm using the GitHub, GH auth login. If I'm using the regular way of pushing and pulling, it would still be the same as long as I have authentication. Yeah, yeah. Okay. We're gonna continue reading this, but real quick, I need to take a break for 2 or 3 minutes. I will take a short break and come back. In the meantime, I'm switching to BRB. I'm gonna mute my mic, and I'm also gonna pause the RTMP feed so that my fans can stop screaming. I'll be back in a couple of minutes. All right, I am back. Let me start up this RTMP feed again and let's transition. And which one was it? This one? Man, dude, once I get this GitHub thing going, it's gonna be great because now that I'm thinking about it, yes, because GitHub allows us to have private repos. So even the projects that I'm not necessarily planning on um, making public, I could have them stored on GitHub as well. I don't usually do that though, if I'm being honest. Um, in terms of having a backup, I usually don't post the private repos. I rarely have like private repos. Well, that's not entirely true. There are private there are words. Holy shit! There are private repos that I have, but I've mostly ever kept them local. I haven't really pushed them to GitHub if they didn't need to be public. I just didn't push them to GitHub. To be fair though, I didn't have this workflow where, I would I also didn't have a terminal based workflow, so I didn't have a very fluid way of, at least not nearly as fluid as it is right now, and as fluid as it's going to be furthermore as I start learning more and more. Um, the workflow that I had was not nearly as fluid as it is now. So now I'm going to be using Git and GitHub a lot more. So that might change things. Maybe I might have a lot more private repos on GitHub, because I mean it would be good. It would be good for having a private cloud backup of the stuff that I'm trying to back up. I I'm thinking about like what's a good way in terms of maintaining a backup. What is a good way to actually have this as a self-hosted solution? Because I mean, the repos themselves are basically just directories. I can copy all of them and you know have them located elsewhere. If it's literally just about making a backup, all I would need to do is copy those directories, copy the bare repos, which again they are just directories. All I would need to do is copy those bare repos, and I can save them anywhere. At some point I should add like a third location. um I mean, two are enough. To be honest, two are good enough, because I could the second one I could start uploading my private repos over on GitHub as well, or I could have three remotes. That's not a problem. It'll just be like um backup O1 and backup O2. Or I can say local central O1, cloud central O1. Cloud central. Why does that term sound familiar? Cloud central. Hold on, let me look that up. What is that cloud central meaning? The term cloud central generally refers to A centralized cloud-based platform or console used to manage, monitor, and configure IT networks, devices, or communication systems. No, no. Um, oh, I, I think I'm remembering South Central, not Cloud Central. Yeah, okay, never mind. Um, so I was having this, I was loading up these conversations with Gemini. I'm just gonna load them up and then we can continue. Um, okay, all right. So going back to, oh yeah, I'd asked Gemini to give me a rundown of what the entire workflow would look like. And I think for the most part, I have what I need because I think when I do the GitHub CLI auth login thing, I think it does store that token in something that Git is able to read, not GitHub, but Git. And because Git is able to read that, so if at some point later I um, try to push to, my GitHub, I try to push to a repo that is, or I try to push to a remote that is linking to a repo um, that is on my GitHub account, then obviously it's going to need the authentication, right? As soon as it asks for that authentication, I'm guessing Git is going to be able to pull that access token and pass that in. And so it's not really going to bug me about it. I think so. I think that's how the flow is going to be. But okay, Gemini mentioned this. Gemini said, and I think Gemini's information might be a tiny bit old, or I'm remembering wrong. Because Gemini said this, okay, you create a working copy. So that's going to be our local working copy where I'm actually doing the work and committing the changes. Then we're going to have a local bare repo. That's going to be our local central repo. That's where I'm going to push the changes to. Um, and then we're going to have a GitHub central repo. That's where, that's also where I'm going to be pushing my changes to. And that's going to be on GitHub. That's going to be on the cloud. So these three things are there. Um, One-time setup, we're going to need to create the local bare repo. We create that. Then we're going to need to create the working project. We create that. Of course, we have to create the repo on GitHub as well. And then we have to link the two remotes. Now, this is what Gemini has suggested in terms of linking. I'm going to paste the thing here. Oh, there. This is what Gemini has suggested. Um, So this is for adding the local remote. We can see git remote add local hub is our nickname. Um, I forgot what it's called, a nickname, right? Yeah, I think it's called a nickname. And then this is our URL because this is a local repo, so it's just a directory path. And then we have the GitHub repo link. But this is the SSH link, which I'm interested in finding out, like, how how does accessing this work exactly? Because the way that we have, I typed out, dem keys at whatever IP address. Same way we have git at github.com and then colon, and then we have um, the username slash whatever the repo's name is. This is what Gemini has suggested. I will have to see if I want to use this flow or if I want to use the HTTPS flow, as in workflow. Okay, so that's done, right? And then the daily flow, the daily workflow, sorry, the daily workflow that Gemini is suggesting here is that once everything is wired up, daily you write code committed locally, then push to your local hub first. That's your first backup. And then you push to GitHub. That's your second backup. Um, Wait, Gemini also mentioned something here. For terminal users, if you want to push to both remotes simultaneously, oh, with a single command, you can add a second URL to your origin remote. Okay, so to do that, it is this. Yeah, this is basically to add two links to one remote. So the moment I push, it's going to automatically push to both. Honestly, I might just do this. I might just do this. Each time I set up a new project, that needs to be, um, that needs to have version control, I'm most probably going to be doing this. Okay, now when you type git push origin main, Git will automatically upload the code to GitHub and copy it to your local Bear repository in one swoop. Why this is great? Okay, yeah, never mind. Okay, what about, okay, so then I asked, what about GitHub authentication? Gemini replied, since you are on Ubuntu and work entirely in the terminal, I'd mentioned this early on, just in case it made a difference. Managing GitHub authentication smoothly is key to, okay, that's fine. GitHub no longer accepts account passwords for command line operations. Instead, you have two primary secure options for terminal-based authentication. One is SSH keys, which is recommended for terminal users. I'm not going to be doing that because I don't have the SSH key thing set up on my end either. The second method is, or the second option is personal access token via, oh, okay, via HTTPS. Okay, okay. You know what? Now it's making sense to me. So, um, if I stick with the personal access token method, what I'm going to be doing is, I think that's actually what I want to go with. Like I've done the GitHub auth login thing. I might need to do it again because I haven't touched that in a bit. But once I've done that, then I would be able to use the personal access token method, meaning I should be using the HTTPS link of the GitHub repo, not the SSH, not the SSH link. Okay, so Gemini mentioned if you prefer to keep using HTTPS URLs, you cannot use regular passwords. You must generate a personal access token, which acts as a dedicated revocable password for your terminal. So you generate the token within your GitHub settings, give it a note, okay, scroll to the bottom, generate token, okay, then cache it. So Gemini gave this command for caching it. I I think I was going to do this until I noticed that um, Git just handles it. So like when I once I did the GH auth login thing, then when I wanted to push changes to GitHub, um, GitHub wouldn't ask me for authentication anymore, neither would Git. So I'm guessing wherever the auth login subcommand stored the private access token, personal access token, Wherever it stored it in a location where Git also looks. And so Git is just able to read that, and we've got no problems. Okay, now going back to, wait. Okay, so let's say I use Pat. Should I be adding the HTTPS URL in the remote, or the HTTPS URL, or the SSH URL in the remote? Sorry, zoned out. Okay, if you choose personal access token, you must use the HTTPS URL for your remote. Here's why. HTTPS URLs prompt Git for a username and password. This is where you hand Git your personal access token. SSH URLs bypass the username slash password system entirely and look for an SSH key file on your computer. If you try to use the pat with the SSH URL, Git won't even ask for it. It'll just give you a permission denied error. Okay, now this is reminding me that I was trying to find out what the difference would be between SSH here and Git, because there are two separate protocols being mentioned here, right? We've looked into file. There was also another question that I'd asked. Git remote add. Okay, okay. Where is it? Yeah, HTTPS versus SSH. I had asked this question to Gemini. I guess that question has been answered already. Um, yeah. The question has been answered already. Though Gemini did give a bit more information here. I think I'll save this for reading off stream. For now, we can continue with this. Give me just a second. Yeah, okay. So, um, the pros, so and so, so and so. Okay, if you and a coworker are working on the same project and they want to check out something, running a command like git pull so and so is often easier than them pushing to a remote server and you subsequently um, fetching from it. The cons of this method are that shared access is generally more difficult to set up and reach from multiple locations than basic network access. If you want to push from your laptop when you're at home, you have to mount the you have to mount the remote disk. Hold on. Yeah. You have to mount the remote disk, which can be difficult and slow compared to network-based access. Okay, I think I get it. Um, Finally, this protocol does not protect the repository against accidental damage if every user has full shell access to the remote directory and there's nothing preventing them from changing or removing internal Git files and corrupting the repository. Okay. All right. Cool. Then the HTTP protocols. Git can communicate over HTTP using two different modes. Prior to Git 1.6.6, there was only one way it could do this, which was very simple and generally read only. In version 1.6.6, a new smart a new smarter protocol was introduced that involved Git being able to intelligently negotiate data transfer in a manner similar to how it does over SSH. Okay. In the last few years, this new HTTP protocol has become very popular since. Okay, are they referring to the HTTPS protocol? Okay, there's smart HTTP and dumb HTTP. We're gonna go into both of them. Um, then there's the SSH protocol. What about the Git protocol? Finally, we have the Git protocol. This is a special daemon that comes packaged with Git. It listens on a dedicated 9418 it listens on a dedicated port 99418 that provides a service similar to the SSH protocol, but with absolutely no authentication or cryptography. In order for a repository to be served over the Git protocol, you must create a Git daemon. Okay, so I'm not using Git then. I'm not using the Git protocol. Then I'm directly using actually, I'm not even using SSH for that matter. I can't remember if SSH denies me. I don't think it denies, dude. No, no, I don't think it denies. I'm pretty sure I was able to, as in, sorry, I should say what the whole thing is. I don't think it denies you access if you don't have the SSH key set up. I think it'll ask you for the password. Because that's how my SSH works right now. I haven't set up any SSH keys. Each time I have to do an SSH action or operation, I have to type in the password. I've set it up in that way on purpose. Um, and I think that's allowed in Git as well. But to be sure, I think what I'm gonna do is try and clone. Yes, yes. Okay, I'm gonna try and clone. I wonder what happens if I just clone a repo. As in, which protocol is being used if I just clone. I guess it would depend on the link that I give, right? So if I do git clone and then I give the SSH, um, what's the thing here? It's this, right? So then, is this how we do it? Git clone so and so? I think so. Yeah, I think so. And yeah, I mean, if that ends up being the case, I'm, to be honest, I'm still not going to be using SSH because I have no reason to. Though the SSH thing is mainly going to be for my local network related stuff. I'm not going to be using it for any of my GitHub related stuff. For the GitHub related stuff, the authentication is already handled, and then I'm going to be using HTTPS. I'm mainly using SSH for local stuff because I have an SSH server set up and it can handle all of this. Yeah, yeah. Okay. That answered the question. Let's continue reading. Was HTTP the next one? Yeah, yeah, yeah. Okay, Git can communicate. Right, we've read that already. In the last few years, this new HTTP protocol has become very popular since it's simpler for the user and smarter about how it communicates. The new version is often referred to as the smart HTTP protocol and the older way as the dumb HTTP protocol. We'll cover the newer smart HTTP protocol first. So, Smart HTTP. That is not easy to say. Not the smart part. HTTP. Holy shit. The smart HTTP operates very similarly to the SSH and GET protocols, but runs over standard HTTPS ports and can use various HTTP authentication mechanisms. Meaning, it is often easier on the user than something like SSH, since you can use things like username and password authentication rather than having to set up um, SSH keys. I'm gonna ask this question to Gemini. I'm learning um, Git. I'm gonna pose a scenario to you, and I want you to tell me how um, it's. Tell me what the result is gonna be. So on, uh, so I have two machines, MO1 and MO2. On MO2, I have um, an SSH server running. Uh, on MO2, I create I create a repo for my project. This is my working copy. I then create a bare repo on the same machine, which is meant to be the central repo for the project. I then add that central repo as a remote in the working copy repo and push from the working copy to the central repo. Okay, cool. Now I have the working copy and the central repo, and they are both synced up. Keep in mind, they're both on the same machine. Now, on MO1, I decide to clone the repo from, I decide to clone the project, but from the central repo that resides on MO2. In my git clone command, uh, which protocol and link would I be using? Is this happening over HTTPS? Doubt it, because I haven't set anything up for that. Um, is it happening over SSH? That's a possibility because I do have an SSH server running on MO2, or is it happening over the Git protocol? Uh, I don't even know how that would work because I don't really have a Git daemon set up. Also, what is the right way to set up the working copy on MO1 other than just a simple git clone command? Damn, that was a long prompt. Okay, Gemini replied, you've set up a classic self-hosted solid self-hosted Git environment. It's a great way to really understand how Git treats remotes and how Git treats remotes as just other folders or servers. Let's break down exactly how machine 1, which is MO1, is going to talk to machine 2, MO2, and then look at the best ways to handle that working copy. Which protocol and link are you using? You hit the nail on the head because you haven't set up a web server like Apache or Nginx. Nginx. I'm sticking with Nginx. It's the first pronunciation that I'd come up with for this thing until I found out that it's called Nginx, and then I was like, I'm sticking with Nginx because it sounds cooler. Okay. Right. Since you haven't set up a web server for HTTPS, and you haven't started a standalone Git daemon for the Git protocol, you will be using SSH. Okay, Git has built-in support for SSH. When you run a clone command over SSH, Git connects. Oh, in that case, I guess what I would be doing is basically let's let's say the repo is called some repo 02. I guess the command would be this git clone dem keys at 192.168.8.100 slash, and then we can do home scratch stuff. um oh wait, home dem key. This is going to start um loading up the directory from here locally. But yeah, okay. Well, okay, not even an empty directory. I yeah, I do have some repo O2. Where is it auto completing from? Okay, whatever. Some repo. Some repo O2. Probably dot git, I think. Yeah, we still need the dot git. I'm guessing this is going to be our clone command. I'm probably not going to be cloning. Like, to be fair, I'm most likely not going to be cloning unless something happens to my, working copy, and then I need to, create a clone and start over again. Then yeah, I might be cloning, but for the most part, I'm probably not going to be cloning if it's my own project. But this does satisfy my doubt about which, what do you call it? Which protocol is going to be used. Yeah. Okay. Is git clone the right way? I'm continuing reading Gemini's answer. Is git clone the right way, quote unquote, right? Actually, yes. A simple git clone is exactly the right way to set up the working copy on MO1. There isn't a secret, quote unquote, better way to do it. When you run git clone, Git automatically handles three major things under the hood that you would otherwise have to do manually. One, it creates a new folder on MO1 and initializes a hidden.git folder inside it. Two, it downloads all the history and checks out the default branch, usually main or master. And three, crucially, it automatically maps the source URL as a remote named origin and tracks the default branch. Okay, okay. I find this workflow kind of interesting, but I guess it's because there's no better way to do this. Because, like, in order to initialize the bare repo and set that up as our central repo, we have to first create the working copy. We create the working copy, and initially that is our only copy of the repo, right? We then create a bare repo. which doesn't have anything in it. And from this working copy, we push changes to the bare repo. Now the bare repo is the central, is what we are conceptually considering the central repo, right? Because that's our bare repo, and that now has all of the latest information. And further from that point, anything, any new changes that we make in our working copy, we're going to be pushing it to that bare repo. If anything ever happens to the working copy, we can just pull from the working, we can just pull from the bare repo, from the central repo. So the central repo at that point becomes, or the bare repo at that point becomes our central repo, which initially started out as an empty repo, and it was actually made after the first copy, after the working copy. That's kind of like, I mean, that's how, that's the workflow that we are following. I just found it kind of interesting that like that's the way that we go about setting this up. Though to be fair, I think that's how we do it on GitHub as well, assuming we are going with, you know, the terminal based workflow, and not using something like GitHub for GitHub Desktop. GitHub Desktop is GitHub's. I don't remember if it was called GitHub Desktop or Desktop GitHub or GitHub for Desktop or something like that. But that was their what do you call it? That was their GUI. That was their front end for GitHub related operations. So you could do a lot of very basic and even slightly advanced, but like a lot of very basic Git operations through it. So you could do you could stage files, you could commit files, you could, well, you could stage changes, you could commit changes. I believe you could also create branches. You could probably also, oh yeah, that was definitely pushing and pulling. You could do that for sure, because the repos that you were cloning there, you would be connecting, like they would be cloned from GitHub. There was a way to do like the local thing as well, and it usually is reading from like a git, it's reading directly from one of the, from the git config. I remember this because on my Windows machine, when I tried changing the username and email, and then I tried opening up GitHub, the GitHub desktop client, it was, there was a change. I think the repo wasn't showing up, or it didn't have access to the right account, or there was something, there was some change that happened. So I knew that it was, uh, if I'm setting global settings, those global settings are being, they are affecting a bunch of different things, including the GitHub desktop front end. Okay, all right. Um, okay, Gemini also mentioned this, an alternate way, if you want to do it manually, just to see what clone saves you from having to do. Um, then you would create the directory. You would cd into the directory. This is what this is like, follow up from. This is a continuation of Gemini's previous response about what exactly, like, is it, is git clone just the, is git clone the best way to go about this? Is that all, is that all we need to be doing, or is there a better way to go about it? Turns out no, git clone is the best way to go about it. And now Gemini is explaining that if you wanted to do this manually, you would have to create the project directory first. So this is, at this point, it's going to be an empty directory. You would then cd into the directory. You would then initialize a repo in that directory. Then you do git remote add origin, where you add the the ssl ss. Why do I keep thinking about ssl? Where is that from? Secure socket layer. SSL. Hold on. I'm remembering. I keep thinking of SSL. I haven't heard this in a while. Secure socket layer is an internet security protocol that establishes an, okay, yeah. So this is It's secure socket layer that I was thinking of. Um, Although officially replaced by TLS, the term SSL is still universally used to describe that um, the technology that keeps your online data safe. Oh, that's why. Okay, it's because when we are talking about online encrypted stuff, we have HTTPS, but we also have SSL. These are um, two different types of secure communication mechanisms that would be used. SSL uses like a whole other thing. Okay, that's why I was thinking about it. Okay, all right. Back to this. So we would do git remote add. So we would add the repo, the central repos link as a remote in this empty repo that we have just created. Then we fetch origin and check out main. Okay, okay. Oh, wait, that's interesting. So we fetch origin and then check out main. How is the checkout command just working with main? Wait, okay. Let's talk about your manual steps for a second. Help me understand what's happening in git fetch origin uh, followed by git git checkout main. Okay, let's zoom in on those two steps because they actually highlight one of Git's coolest design features. Everything is local. Unlike older version control systems, where I think it's about to explain how fetch works to me, where every command talks to a central server, where every command talks to where was I? Oh, talks to a central server. Git keeps a complete miniature copy of the remote database right on your hard drive. So here I think it's about to explain remote tracking branches to me. Um, so git fetch origin. Think of git fetch as a safe data gathering download. It reaches out over SSH to your central repo on MO2. Keep in mind, MO2 is where we have our initial working copy and where we also created the central repo. It reaches out to your central repo on MO2, looks at what's there and downloads any history, so commits, files, branches, etc., that MO1 doesn't have yet. However, it does not touch your actual workspace files. It stores this downloaded data in a hidden read-only holding area called remote tracking branches. In your scenario, after running git fetch origin, your local Git database on MO1 creates a pointer called origin slash main or origin slash master. So that's going to be, yeah, that's going to be our remote tracking branch for the main branch. For the main branch on the central repo, that's the important part. Okay, the state of your folder. If you open your project folder on MO1 at this exact moment, it will still look completely empty. The files exist inside the hidden .git folder, but they haven't been unpacked into your workspace yet. Then comes git checkout main. Now that MO1 has all the data safely downloaded in its hidden database, git checkout main tells Git to actually materialize those files so you can work on them. When you run this command for the very first time on a fresh repository, Git does three things. Now, okay, I'm thinking about how git checkout works, because so far we have checked out commits within our um, within our commit graph. So these are commits that we've already made. So far, I haven't looked into checking out branches. I'm assuming when you check out a branch, it's also going to change the state of the working directory to match whatever is within the branch. Okay, cool. Is that exactly what's happening when we check out the the remote branch? But then what how do we, like, do we not end up in a detached head state? Because that's usually what happens when we Oh, that happens when when we are not pointing to a branch. It happens when we are pointing to a commit specifically. Detached head state. Detached head state is when um sorry, um losing my words. Detached head state is when head okay, I'm getting it back. Detached head state is when head is not pointing to one of the branches, but rather pointing to a specific commit, because usually head is supposed to point to a branch and then the branch points to its latest commit. Um, if head is pointing to a commit directly, that means it's in a detached head state. So then, does that same rule apply if it's a remote tracking branch that head is pointing to? Would head even be pointing to a remote tracking branch? Let's take a look. When you run this command for the very first time on a fresh repository, Git does three things. It looks at the holding area. It sees that origin/main exists thanks to the fetch you just did. It creates a local branch. It automatically creates a brand new local branch named main and points it at the exact same commit as origin/main. Okay, it unpacks your files. So it takes the snapshot of files from that commit and dumps them into your project folder. Now suddenly your code appears. Why are they separate? The Git philosophy. Git separates these two steps so you are in total control. You know what? I get that. Okay. Wait, help me understand this though. Um, Couple of things. I remember there being an issue where I tried to pull from a repo that was a completely unrelated project, and I got a fatal error saying something about unrelated histories. How does that not happen here? And then the second one is, help me understand how with git clone main, git knows that it is supposed to look at origin/main and then more or less create a copy of that, or no, more or less recreate that in main. Also, what is happening with head at this point? Because isn't head supposed to point at a branch? I know that when you point it at a commit, it becomes a detached head. But what about when you point it to um, a remote tracking branch? I guess I'm trying to understand. Hold on, I forgot that last question. What was I trying to understand? I guess I'm trying to understand. Damn, forgot the question. I guess I'm trying to understand. Wait, okay, but what about when you point it to a remote tracking branch? Oh, yeah, I guess I'm trying to understand how Git checkout is making all this happen. I don't think that was the question though, but yeah, anyways. You are asking some incredibly sharp questions. These are the exact mechanics that separate people who, yeah, okay, that's great. Thank you. Let's tackle these head on, starting with the unrelated histories error, and then we'll map out exactly what head and checkout are doing. Why don't you get the unrelated histories error? The reason you don't get that error is that the history isn't unrelated, it is the exact same history. Git doesn't look at the name of your folder or your project to decide if histories match. It looks at the directed acyclic graph, which is just a fancy term for a chain for the chain of parent and child commits linked together by their unique SHA-1 hash IDs. In your scenario, you made a repo on MO2, made some commits, and pushed them to a central repo. When you run git fetch on MO1, you are quote you are downloading, I was about to say quote unquote, but yeah, you are downloading those exact same commits with those exact same hashes. MO1's history is a direct descendant of MO2's history. How? I don't get that. I don't get that. Okay, hold on. What caused your past error? The fatal refusing to merge unrelated histories error happens when you have two repositories that were started completely independently. Example, you ran git init in a folder on your computer, someone else ran git init in a different folder, and you tried to force them to merge. Because they don't share a common root or initial commit, Git panics and says, these are two entirely different universes, and I don't know how to stitch them together. How does Git know to map origin slash main to main? This is a built-in feature of Git checkout called guess mode or tracking branch auto creation. When you type git checkout main, Git goes through a very specific checklist. It looks at your local branches and says, do I have a local branch named main? No, you don't. Remember, you just ran git init and git fetch. Instead of giving up, it looks at your remote tracking branches. It says, is there exactly one remote branch that matches the name main? It finds origin main. Because it finds a perfect unique match, Git guesses your intent. It says you want to work on main. Let me create a local branch named main for you. Point it at the same commit as origin slash main and set up a tracking relationship so git pull works easily in the future. Note, you mentioned git clone main. Oh, no, I meant checkout. Yeah, yeah, okay. Yeah, yeah, yeah. I meant git checkout. I accidentally wrote git clone main. Let me just confirm. Yeah, yeah. I wrote that. Um, okay. All right, what's happening in head during all of this? To understand head, remember the golden rule. Head is simply a pointer that answers the question, where am I standing right now? Normally, head points to a local branch, and that local branch points to a commit. It's a pointer to a pointer. Okay, cool. What about pointing head to a remote tracking branch? You guessed right. If you were to explicitly type git checkout origin slash main, you would put yourself into a detached head state. Sorry, zoned out. Um, why? Because origin slash main is a remote tracking branch. In Git, remote tracking branches are read-only markers. They represent where the server is. Git will not allow you to stand on origin slash main and make new commits because you can't directly grow a remote marker. Okay. So if you check out origin slash main, Git detaches the head from the local branch and points it directly at the commit hash. The step-by-step dance of git checkout main. Going back to our manual steps, here's how head moves throughout the process. Right after git fetch origin, you are on a blank local repository. By default, git starts you on a default local branch, let's say main, but it doesn't have any commits yet. Head points to local main. Local main points to nothing. It's an unborn branch. Origin slash main points to commit so and so so and so. Step B, you run git checkout main. Because of guess mode, Git realizes what you want to do. It takes your unborn local main branch and anchors it to the same commit as origin slash main. I just realized, why am I looking so deep into this? This was describing the manual method. I'm not going to be doing the manual method. I'm going to be cloning the repo. I'm I'm not doing the manual method. But it's good to know that this is what git clone is saving me from. This is what git clone is doing that I don't have to do manually. Okay. Head still points to local main. Local main now points to commit so and so. The files from commit so and so are unpacked into your folder, and because head is a safe is safely pointing to a local branch main. Sorry, zoned out. Um, because head is safely pointing to a local branch main, you are not in a detached head state. You can safely write code, type git commit, and local main will move forward normally, while origin slash main stays behind until you push. I still don't fully understand this. Yeah, I still don't fully get it. Um, but I'm going to continue this off stream. So that's going to be it for today's stream. I'm going to end the stream here and I'm going to continue with this research. And I'm probably going to finish learning about remotes. And then tomorrow, maybe we can look into branches. Hopefully, I set up the whole GitHub workflow and also the Bear repo workflow. And once I have that set up and I know that I'm able to do it seamlessly without having to worry about entering credentials and without having to worry about any information being exposed, sensitive information being exposed. Once I'm comfortable with that, then I can do that on stream as well. But that's going to be it for today's stream. We made some good progress today. We made some great progress today, actually. Holy shit. And we've been going for an hour and 42 minutes, which is awesome. That's pretty great. But yeah. Good progress today. I'm going to continue making progress off stream. Hopefully, before tomorrow's stream, I've set up the remote thing. I've cleared all my doubts. This right now is just about my curiosity thing, and then I'm going to move on and look into setting up the workflow for both the local central repo and the GitHub central repo as well. Hopefully, tomorrow's stream is going to focus mainly on branching and then possibly on tagging as well. We are getting so close, dude. We're getting so close. So close to continuing with all the other stuff. But yeah, dude, that's going to be